So we'll continue with sections 4.1 and 4.2. In this example, you're given a function f of x and you're asked to find absolute max and absolute min on the interval 0, 5. So first, let me rewrite the function as x minus 4 to the negative 2. You want to bring all the exponents to the numerator and write it, so applying the power rule will be more easy. Now, let's calculate the vertical asymptote. Vertical asymptote at x equal to 4 is defined as limit of the function when x is approaching 4 from the left, 4 minus f of x, and limit of the function f of x when x is approaching 4 from the right, so 4 plus. So the graph of the function 1 over x minus 4x squared looks like this. At 4, the vertical asymptote, you see the graph of the function is going to infinity. So let me draw the graph here. So I can write when x is approaching 4 from the left, in this direction 4 minus, the function goes to infinity. Similarly, when x is approaching 4 from the right, 4 plus, the function goes to infinity. So you are not going to see a maximum in this graph. So for sure you can write there is no absolute maximum. Now you want to find the first derivative f prime x. So apply the power rule of differentiation for f of x. F of x is x minus 4 to the negative 2. So when you do the power rule of differentiation, you get negative 2, x minus 4, negative 2, negative 1. So you can write it as negative 3. Then you write negative 2 divided by x minus 4, the cube. So when you see this expression and try to solve for x, you understand that there is no critical point. So you can write critical numbers, and then there are no critical numbers, so you can write none. The reason is the critical point calculation looks like this. When you want to find the critical numbers, all you do is you find the f prime and you equate it to 0, and then you solve for the value x, the unknown x. When you try to do a similar calculation for this example, what you might end up is getting a negative 2 over x minus 4 the cube equal to 0. So such type of fractions you want to cross multiply to simplify. When you cross multiply, all you get is negative 2 equal to 0, which means you will not be able to solve for x, as well as negative 2 equal to 0 is not a correct valid expression. So all you say is there is no value of x which can satisfy this equation, so there are no critical values. Now you want to calculate f at 0, which is 1 over negative 4 the square, which is 1/16th, and you want to calculate the functional value at 5. These are the boundary points given for you in the problem, 0 and 5. So this is 1 over 5 minus 4 the square, 1 over 1, which is 1. So now you see the minimum value is at 1 over 16. So you say absolute min is 1 over 16. The next one is the Rolle's theorem. Let f be the function that satisfies the following three hypotheses. Number 1, the function should be continuous on the closed interval ab. Number 2, the function is differentiable on the open interval ab. Then the functional values at a and b should be equal. The function is continuous on the closed interval AB. You should have a smooth curve. Say this is your interval AB. So inclusion of the endpoints AB, the function should be continuous. The function should be differentiable on the open interval AB. So leave out the endpoints, and then in every other point other than the endpoint, you should be able to differentiate the function. The derivative should exist. And the functional values at A and B should be equal, which means it's a graph of equal height at A and B, and we are seeing that. So when you have all these three conditions for the function f, then you can say that there is a number c between a and b such that the f prime c equal to 0. So you have a c between a and b. So at c, if you try to draw a horizontal tangent, the f prime c will be 0. So let me draw one more graph where I have endpoints as ab, and I have several points like c1, c2, c3, and c4. So the curve here should look like this, which can satisfy this definition. So at C1 you will be able to draw a horizontal tangent, at C2 again, at C3, and then C4. So at these 4 points the derivative of the function will be 0, and the endpoints are included in this graph. The next is the mean value theorem. Let f be the function that satisfies the following hypothesis. Conditions are: the function should be continuous on the closed interval AB, and the function should be differentiable on the open interval AB. These are similar to the conditions on the previous theorem, Rolle's theorem, except that the functional values at the endpoints may not have to be equal, whereas for the Rolle's theorem you have f at A and f at B are equal. So a suitable graph which satisfies all these definitions in this theorem might look like this. AB or the endpoints. So this is your FB value of the function at B. This is your FA. So you are seeing that FA and FB are not equal, but still you are seeing that the graph is continuous on the closed interval AB and it's differentiable on the open interval AB. So the derivative should exist at all the other points. And at these points C2, C3, you are seeing that you are able to define the slope is 0. Now the theorem says that there is a number c between the a and b such that when you want to define the slope, you can define the slope as fb minus fa divided by b minus a. So you take the endpoints. This is your typical formula from pre-calculus, rise over the run, and you calculate the slope. So if you draw a horizontal, not horizontal, a slant line. So let me change the curve a little bit. You should be able to calculate the slope of the curve at any point C1 and C2. And I would write that the slope of this curve will be FB minus FA divided by B minus A. In the next example, find a number C that satisfies the conclusion of the mean value theorem on the interval 0, 2, and the function given is a cubic function x cubed plus x negative 1. So first thing you want to check is if this function is continuous. These are polynomials, so they are continuous function. Then you would check if this function is differentiable. And the answer is still yes, this function is differentiable. So having known that the function is continuous and differentiable, you would like to do the derivative f prime, which is 3x squared positive 1. Then you calculate the derivative at the point C, so you will write this as 3c squared plus 1. But now you want to calculate the value of C before you proceed. So from mean value theorem, you're going to write f prime C is value of the function at the endpoint f2 minus f0 divided by 2 minus 0. Then you want to write f prime C as 3c squared plus 1 from the left hand side. f2 is 9, calculate the functional value at 2. Similarly, calculate the function value at 0, you get negative 1. Then in the denominator, you have 2 minus 0. So you have 3c squared plus 1. 9 negative of negative 1 is positive 1, so it's 10 divided by 2, and your answer is 5. So you're going to write 3c squared is 5 minus 1, which is 4. So you can write c squared is 4 divided by 3, or you can write c equal to plus or minus root 4 over 3. But when you split the signs, say you have a root 4 over 3, and then you have a negative root 4 over 3. Now you want to cross out this value, negative value. The reason is this is lying outside the boundary 0 to 2. You want to pick a value, any value between 0 to 2. You cannot pick negative 4 root over 3, which lies here on the negative x-axis. So this is negative root over 4, 3, and this is positive root over 4, 3. So you go with this and you neglect the negative value. So you want to say on the 0, 2, the value of C that satisfies this mean value theorem will be root 4 over 3. So this is your final answer. In the next example, you enter a toll road at 8 a.m. and then you want to exit the road at 9:15 a.m. The distance between the entrance and the exit is 100 miles. If the maximum speed is set to 70 miles per hour, do you get charged for speeding? So let's try to use the theorems what we learned in this section to answer this question. Say at x equal to 0, the functional value will be f at 0. Now we want to define x here as a time variable, which means it is 1 hour and 15 minutes. That is the time taken to enter and exit and travel 100 miles on this toll road. So I can write this as 1 plus 1/4. 15 minutes is 1/4 hour. So I'm going to write this as 1.25 hours when I sum these fractions. Then I would like to calculate the functional value at 1.25. So at the end of 1.25, the distance covered will be 100. So I'm going to write it as 100 miles. Now let me write the mean value theorem, which says that f prime C is fb minus fa divided by b minus a. So you want to carefully observe the end points b and a here. So this will be functional value at 1.25 minus functional value at 0 divided by 1.25 minus 0. F at 1.25 is 100 and functional value at 0. At 0, the distance covered is 0. Times 0, the distance covered will be 0 because you are in the starting point. So f0 is 0. So it's okay for you not to write. Do the difference in the denominator 1.25. Simplify. You have 80 miles per hour. So with the help of the mean value theorem, we are able to see that if the maximum speed is set to at 70, do you get charged for speeding? Then your answer is 80 miles per hour. So if you use the mean value theorem, you're able to answer this question. We'll end the section here.